Anyone? Testing? Okay. That's funny. I can't hear any of you.
All right, while we wait, do we have a volunteer for to be a note taker? Who wants to be the note taker?
I'm gonna log out, log back in. See in a second.
I'd be happy to take notes, except during my slot again. If you don't have another volunteer you like better.
Jake, you got the job. And does anyone want to take notes while Jake is presenting? Kyle, you up to the task?
Yeah, I'll do it.
Awesome, thank you.
All right, I hear you now.
Cool, we hear you, Greg.
Thanks, Kyle.
All right, we can wait another.
I do see my slides. Are you not able to see them in the meeting? Here, let me give you the link I'm looking at.
I do see them in the meeting manager, Jake.
Okay.
But where I don't see them is, you know, the little button next to join the queue. Slide. It's the share slides.
Okay.
Do you see that button?
Yeah.
For some reason, your deck didn't make that list.
That's exciting.
Only your deck. Only your deck, though. So, are you cool to present yourself? Just share your screen.
Yeah, that should be fine.
Okay. All right. We can wait. Greg, how much longer you want to wait here? Give it another minute or so.
Yeah, another minute. I mean, agenda's pretty small, so this is really the Jake show. It's a head count now.
It's going to be way shorter than my slot there, I think. So we should have plenty of time left over, I hope.
Yeah. And you guys can see the note well right now.
Noted.
Great.
I'll mute that.
All right, I think we're a couple minutes in, so I think we could probably get started here. We've got that all-important 18th person. So, all right, well, welcome to MBONED. For those on the West Coast, thank you for waking up so early. Here is the note well. Please note it well. Here's our agenda for today. It didn't render as nicely as it did in PowerPoint. Anyone have anything to add or bashing to be done to this agenda? Okay. All right, so we'll get started with, here's the list of currently active working group docs. The Wi-Fi multicast problems draft, after a long journey, has finally made it to its final resting place as published as RFC 9119. Congratulations. Thank you to Mike for getting us across the finish line with all those final discuss items covered, and that whole team, Warren and others who, other authors, congrats. The Yang models draft, Sandy, do you want to have anything to add here? It sounded like you said you updated it based on the Yang doctors and a couple other reviews. You'd like one more review before a working group last call. Anything else, Sandy, you want to add to that? All right. We'll assume Sandy's good with that update. We have the multicast to the browser drafts. Jake is going to cover these today. The telemetry draft. How you mentioned that there's a plan. It's related to the IOAM draft doc that's soon to be an RFC, and there's a plan to update the draft after that and resume. We'll have more discussion on that next IETF. And there's another doc, redundant ingress failover, and Yisong will provide an update on that one today, and we'll probably, unless there's major objections, begin a working group adoption call after that. So that's everything so far. That is all the drafts we have. First up, let me stop here. Tommy, you are up. You can share your screen, or you can share preloaded slides. The share preloaded slides button, which is next to the join queue button, works reasonably well.
I'm requesting. Yeah, here we go. Thank you.
All right, so we invited Tommy.
Slides.
Yeah, so let me just give a little intro here. So we invited Tommy from Apple to join us. iOS announced recently a new entitlement program for applications that want to utilize Multicast, and there were some folks in the working group who were kind of curious about this process, so we invited Tommy on to basically describe the process and what led to it, and any experiences they've been having at Apple with support of Multicast. So with that, Tommy, I'll turn it over to you.
All right, thank you. And this should be a pretty quick update here, but we do have time in the agenda, so I'd be happy to have discussion, questions around this, and suggestions of what you'd like to see going forward. All right, so what are we talking about? So specifically, this new entitlement, and an entitlement for people who are not familiar with it on at least Mac OS and iOS is essentially a privilege that has to be signed into the binary of the application when it's before it can be released on the App Store. And some entitlements you can just kind of check a box. This is one that you have to request. So it's a little bit heavier weight. Anyway, this is part of a general suite of changes that we did to add restrictions around what you could do on the local network. And these are all aimed at trying to improve user privacy from various types of attacks. And so this was introduced in iOS 14. So that means we announced this in our developers conference, which occurred in June of 2020. So, a year and a half ago. And the release came out over a year ago at this point. So this has kind of been the reality for the last little bit. And there are several different changes that were part of this local network privacy feature overall. First, all apps that are communicating with hosts on their local network, whether that's Unicast, Multicast, using APIs that will trigger local network interactions, they all must get user permission before communicating. So, it's assumed that if I'm using an app, sure, maybe it's talking to the internet and to the wide area network, but before it can start, poking into my TV and my printers around me and trying to do stuff, the user just has to give permission. This really makes a lot of local network interactions more consistent with other kind of nearby device interactions that required a similar privacy permission, such as connecting to a Bluetooth device, etc. So a lot of this is about consistency and user awareness. The next category of change is that most of the multicast discovery that occurs on iOS devices is using system APIs for multicast DNS, using DNS service discovery on Apple platforms that's branded as Bonjour. And any app that's using that must declare kind of at compile time the static list of all of the different service types that they plan to use. So they can't use any service type that's outside of that list. They can't just start doing wildcard discovery. And then the third category, which is the one that we're talking about here, is specifically for multicast and broadcast that's not using any system API like what we have for multicast DNS. An app must have an entitlement because this is a kind of even more privileged and powerful operation. So that's what was restricted. But why was this done? A lot of this was done in reaction to a growing trend that we saw in which very surprising apps were doing some arbitrary scanning of the local network that seems really to be a kind of a user tracking device that was becoming more common. So we wanted to make sure that that did not grow further. Oftentimes, functionality like this can be embedded within SDKs that apps link in to get some sort of functionality. And so this is not always code that the developers of apps even realize is being run within their apps, but instead some third-party library that they had linked in that maybe in return for being free was collecting some data about users and user location. And so in general, you would see when we turn this on first, and just to say, hey, what lights up, what starts scanning your network on different ports and on different addresses. It was quite a lot of apps doing it very frequently. And some of these can be legitimate use cases, but a lot of them also could be efforts to detect what devices were around, what types of things would respond on the local network, to create a signature of the local network that the user is on currently. We had, for years before, prevented apps from getting directly at some of the SSID or BSSID information to know, oh, the user is currently in this location, as a way to evade getting location permissions if they didn't think that the user would grant location tracking. Now, in general, as I mentioned, for Bonjour, we kind of started preferring APIs where you could list a specific service type. So this guarantees that the app developer is aware of what they are doing. So if I have an app that's trying to talk to a printer, or I'm trying to discover a TV that I can display something on, indicating at the app compile time, yes, this is the type of service I'm trying to do. Or maybe I have a custom service for my own special devices, or I'm doing some peer-to-peer game. If they can specify, here's the exact scope of what I need to do, it's much easier to guarantee that there's not other code running that's doing nefarious things or trying to do a full address and port scan of all devices around. And then the other aspect here is that there are uses of multicast that we see as kind of the most prevalent as we've been granting these entitlements. By far the most common is, oh yeah, I just want to use SSDP, which is pretty old protocol, not standard, has a lot of security vulnerabilities, and this is also an opportunity to tell people, hey, if you're just trying to do this discovery, going and using a system API that is more audited and using a standard protocol like Multicast DNS is going to be a better route if you're building a new solution. So we're also trying to have people move to preferred protocols when it's possible. So going forward, apps that do have legitimate reasons to need custom multicast can get approved. They just need to fill out a form to say, what are they trying to do? And almost everything does get approved. Generally, what wouldn't get approved is if you cannot sufficiently explain, like, what address and ports are you trying to use? Like, what is why does your app have to do this? Or if they're trying to get around the multicast DNS service type restriction by implementing a custom stack that will let them scan all multicast services around them. And another part of the philosophy going forward is that the common SDKs, like what we have with, there's Google's casting SDK. We worked with them to move to using system-supported APIs and implementations of Bonjour that don't require applications to get entitlements. And I'll point out that right now, the main thing that you can do with an entitlement that is multicast is Bonjour/multicast DNS. That doesn't mean that that has to stay a fixed list. If there are other things that become very relevant for iOS apps that should be kind of built into the system and saying, well, this multicast protocol should be supported as kind of a native protocol that's going to be generic for a lot of different apps, that could certainly be done, and that would kind of fit into the model of making sure that generic apps aren't accidentally putting in some tracking software into their apps. So just some other resources. We have our 2020 presentation on local network privacy in general, and then probably more interesting is this separate article we put out about how to use Multicast. We offered some new APIs around doing Multicast that year that were part of our network framework, and then it also documents how to get the entitlement. And that is all I have. Do you have questions? Hey, Jake.
Yeah, hi Tommy. Thanks for this. I did have a couple of questions. So the MDNS, you seem to say it was Bonjour or DNSSD, but does this distinguish between like just using a .local name that also generally uses MDNS? Or is that also-
Right. So if you use a .local name, that does not require any special declaration of what service types you're using. The special declaration is just for browsing, since that was more like, okay, people are using this to scan, and there definitely are.
Nice.
So you have to also apply for the entitlement if you want to be able to do wildcard Bonjour, and there are utilities that are just about scanning every device around you and reporting this is what your local network looks like. But we recognize that those are usually pretty niche products.
So there's nothing that prevents scanning just according to a bunch of .local names, for example, or is that just a sort of separate consideration?
I mean, yes, you could try to brute force like every possible string in the world. No, note
Or
that
known
that
devices, I
still
guess.
does require the user permission. So like the user will get a pop-up of do you want this app to scan your local network?
I see. Okay.
But
not separate for each .local name, right? Or
no,
yes.
No.
Okay.
You can just
Okay.
say yes or no.
Interesting. All right. My other question, or my second question, maybe. Are there any differences between SSM and ASM, or between globally or locally scoped addresses?
No, we're not doing any distinction there currently.
Okay. And then my last question was, are there any sort of known changes you anticipate to this going forward, or you think this kind of covers the sorts of efforts you've seen, and nothing else would be necessary?
No changes. Kind of, we just released iOS 15. That stayed the same. That's pretty stable. I would love to hear from you or from people in the group, like, what raised this to your attention, and are there use cases that you think should be common enough that they shouldn't require an entitlement, and what is that, and how could we create a graceful path for those?
Sure. I can answer for myself, at least. There was an article forwarded where someone was kind of bemoaning the extra bureaucracy for just experimenting with multicast in an app development sense, saying kind of multicast is hard enough. I think that had some sympathetic ears on the list when it was forwarded, but you know, I mean, we've been working on the security and noting the. I don't know if you saw the draft in SecDispatch right after your slot, but yeah, there are some sort of potential exposures. And so yeah, I didn't think it was necessarily a bad thing as long as it's not a sort of onerous process. So just for my own opinion there. And I think there were some other takes on it.
Yeah. I know that there are a handful of people who've requested to have kind of complained. for doing experimentation, our simulators Macs work just fine without the restriction. It's really just the iOS devices here, and they specifically, oftentimes if there are requests for just like, oh, I'm doing experimentation, it's often just to discover like peer-to-peer, like, hey, where's the other iPhone around me? And for that, I think we try to steer people to saying, hey, just use the system APIs for discovering your app's service nearby. That works just fine. Why are you trying to invent a brand new discovery protocol that's not DNS service discovery? It's not SSTP, but you're like rolling your own thing. Like you're probably making it harder for yourself in experimenting.
Sure. Let's see. I guess I suppose you're not willing to name names on SDKs that had suspicious behavior here. Yeah. Okay. Just thought I'd ask. Thanks.
All right. Any other questions? Should we hand it over?
So I think I understand the entitlement process for apps as you're sourcing. So as a user, if you want to join a multicast group, there's no entitlement for that, or do you just get a pop-up that says, do you really want to use multicast? Or so, can you just explain what that looks like for not the app developer but the app user? Is there anything on their part that they need to do, or that just works?
Yeah. Right. So yeah, like an entitlement and the list of Bonjour or multicast DNS service types, that's all a developer problem. They just have to bake that into their app. So assuming you have an app that has permission to use multicast because they got the entitlement, or they're using multicast DNS, or they're just using Unicast on the local network, the only thing the user will see is a one-time pop-up to say, do you want to let this app use the local network? And you can say yes or no. You can go back and change that decision in settings at any point. But it's pretty coarse grained at that point of saying, is this expected? The app does get to pre-populate that prompt with an explanation of why they use the local network. So the user can say, like, oh, they're doing this to X. And then we've encouraged people to have that show up when you're actually starting to do something that the user wants, not just like at the time you launch the app. But that's all the user would see.
Gotcha.
They generally don't have a way to kind of manually there's no terminal console on these devices, so they can't like manually do some commands that will trigger multicast.
Gotcha. And did you mentioned this isn't a can you give any kind of experience in terms of, you mentioned, are there lots of apps that have applied for this entitlement? Did you say you guys haven't denied anyone?
No, I mean, some people, there have been some we have not approved.
Mm-hmm.
The vast majority get approved because the vast majority are legitimate.
Gotcha.
Yeah, I mean, it's a bunch. I mean, I think it's thousands.
Great.
I ask a question there too. And so I'm not looking for names, but those that you said that were not approved, is this in the general case because you can point them in a direction of something that already exists rather than reinventing something?
Exactly. Oftentimes they're like, oh, the most common case is they were trying to roll something on their own, and they would said, oh, I can just use this API to discover thing around me. Great, I'll use that. That's the most common reason that they don't end up getting the full entitlement, because they don't need it.
Any
right.
other questions for Tommy? All right. Well, Tommy, thanks for joining us and thanks for sharing this
Absolutely.
information. Very, very helpful.
Thanks, everyone.
Next up is Jake.
Let's see. I think this is my first time sharing the screen, so let me see if I've got this figured out properly. Okay. I think I can. What's this say? Yeah, okay, that's fine.
Curious, was that the share slides button you used?
Yes, that is.
Preloaded or
Well, that is actually no. That's the request screen share.
Okay, got
Lenny
it.
told me at the beginning there that that for whatever reason my particular slides were
Yeah.
not in the preloaded list for some reason. I was probably late. Great. So thanks. I have just a short update this time. In the notes, I added a link to my last presentation at 111. If you do need any background on these drafts and kind of what they're doing, I'll refer you to take a look at that one instead. I don't want to run through the overview of them each time, so I'm just going to skip that. Mostly what I'm going to cover is the sort of progress in that's relevant to this work that's been happening externally, though I will touch on the relatively small amount of forward progress on these docs and discuss that a little bit, and then I'll go over kind of what my next steps are in this direction. So the first thing is that the Multicast community group has been meeting regularly. We did some stuff at TPAC. Actually, I probably should have posted the link to the demo video that we put up, but that's there in the list of demo videos that they had for the TPAC meeting under the Web and Networks interest group. The Web and Networks interest group in particular had some nice things to say about the Multicast community group and the Multicast use case that they presented during their TPAC meeting. I link the slides there. There's a good, there's some sort of openness to this in the web community. The most compelling part of that seemed to be about or at least the one that got the most discussion was its impact on some of the sustainability efforts that are getting started, and its relevance to that point, which I also highlighted in some of the stuff that I talked about there. And I also had a presentation with the Web Transport Working Group. It was a sort of minor part of their overall meeting, but I've opened an issue requesting that they add multicast as a use case that they would consider valuable, which would be relevant feedback to bring to the IETF Web Transport Working Group and other relevant parties. That is under discussion. I've had a follow-up meeting with the chairs, and they'll be discussing it in the working group to see what they think about that. But that is sort of necessary steps toward moving it to a browser use case. I also presented yesterday in Sec Dispatch about so the background on this, as I think I went over before, but I'll recap it here. We submitted an intent to experiment to Chromium. Their feedback was it's not ready. in particular that it needs confidentiality as well as the integrity and authenticity that was part of the design. In addition to implementation weaknesses that are going to need to be addressed before it can be part of the browser, even behind a command line flag. Totally reasonable, but that's going to be some work. But really, the sticking point was more about the design before even getting to that point. And so confidentiality with multicast comes with some complexity. We tried to capture the complexity in this in the draft Kairos sec dispatch multicast security, and we are looking for a home for it. So in sec dispatch, the recommendation for dispatch was that we start a mailing list. It's to be determined whether that's going to be the MSEC mailing list for the previously existing but closed multicast security working group, or whether that'll be a new mailing list. And that I'm supposed to follow up on, and we'll be sending an email today to kick that off. Hopefully that mailing list will be like in place by the end of the week. I hope, but we'll see, and we'll see if we can get any security experts on it to really dig in on this. We did get some discussion from Ecker on the list. He's sort of against the general idea, and is making the case that nobody's particularly interested, and so there's no reason to look at it. But the objections he raised to it were, on the technical side, were not particularly compelling. I was not able to give him compelling evidence that anybody's interested either. So there might be more such objections if we kind of get to that stage. But I thought the discussion overall was pretty good. I think he had some good points of feedback that we've started incorporating it into the draft to cover it. But this is this security draft is not just about the web safety model, the web security model as it relates to multicast. You know, we intend to do both web and non-web traffic at Akamai, assuming this, you know, actually reaches a deployment stage. And, you know, at the moment, it's looking likely that it will start with the non-web traffic, where we have, you know, we'd be relying on receivers that have some deployment footprint. And this would include potentially some of the gaming platforms for the game downloads, and also some of the sort of smart TV on a stick platforms that that some of our potential partners have some deployment footprint with, and that doesn't have to be web traffic, although being a part of a web API and doing the same thing in all the cases might actually be kind of handy, but not strictly necessary. So we might be able to continue moving forward with some of that. And I think the target still has to include the browser, at least from our point of view, for this to be worthwhile in the end, because there's such a, you know, some of the peaks that the peak traffic days that we hope to address with this work come from web video traffic, and we do think we need to address it. But the sort of next steps on the mailing list front with the security question would, I mean, the target I'm aiming towards ultimately is, well, RFCs with consensus behind them. But to get there, it would take a BOF to open a working group. Again, either the existing MSEC or a new, you know, maybe broadcast media multicast security or some such. I don't know, but you know, because it's a slightly different security model than the previous MSEC work did. So it would either have to come with a recharter, or it would have to be a new working group. I'm not sure what the right answer will be there, and that'll be up for discussion. I'm not sure it'll even happen. It's going to depend on security people agreeing that this is worth looking at, and that they'd be willing to contribute. But we'll try to get that discussion going between now and March, or however long it takes, and hopefully get somewhere. But that's kind of the what it's going to take to get into browsers, it looks like, because the sort of not encrypted at the level that the browser would be maintaining the encryption is sort of a non-starter according to the web security review that we saw. The sort of the APIs we're looking at are listed in the Multicast community group charter in the W3C thing. I think I had a link to the GitHub there, which has a link to the page. Anybody can join that group, by the way. It's not restricted to people whose companies are paying W3C membership fees and whatnot. I should say anybody whose company permits them. There is a contributor license agreement, but you can, as an individual, if your company allows it, make a free W3C account and join the group. So please do if you're willing and able. If your company is a member of W3C, then you might have to get approval from somebody who's sort of heading up your participation with W3C. But for most participants, that hasn't been too big an issue. I'd love to have anyone who was interested enough to come to this meeting might be interested enough to follow this too. I'm particularly interested in people who would be interested in doing the testing and implementation work as that progresses. But that'll be a slightly faster cadence for updates than the MBONED updates. So please do participate if you're interested there and willing to look at the browser work. Let's see, some of the early feedback that we saw from the chat in SecDispatch is suggesting that we're probably going to need to have the actual protocol proposal. So for that, I'm intending to start those experiments, towards the end of this week, and to get these rolling in the coming months. I'm aiming to do a sort of something inside Quick to fit into web transport. So this would very likely be something based on the Pardue HTTP over Quick draft, but there are likely to be some differences with that because I want to make sure to support datagrams to make it such that existing multicast apps can be deployed with just a sort of web transport shim around them at the sending side, and then received by the browser. That's what I'd like to aim for. So the doc status for the MBONED work. I've been engaged on some internal stuff in my day job, and on some of this W3C and working out the security stuff. So I've been kind of low activity on the drafts that are active here, but I did do some updates in dorms. When I checked it against the reviews I'd seen, particularly Rashad's as Yang Doctor, there was an unaddressed comment that I'd left out, so I added some text to address that. So I think as of now, it's got all the updates that people have recommended. If anything has been left out that somebody mentioned, then please do let me know if you see it. It probably would make sense to get at least another review if possible, but I would love to move this to last call at some point and have that get the forward motion that would make the other two that build on it considered more stable. Likewise, the MNAT. I got a few comments, but nothing really telling me to change things, I think. And so I would love to get reviews on that one in particular as well. Ambi, I think I'm going to be messing with as I work on the security stuff. So So if you're looking to hold off on something, you can hold off on that one. Once dorms is done, then CBAC would be certainly a useful one to do as well. But my priority order on reviews, if you're willing to do them, would be dorms and MNAT, and then CBAC, and then AMBI at this stage. Let's see. In MNAT, I'll highlight DNSSD. In particular, the search domain portion of that as the part of the architecture that worries me the most, because it proposes to have a MNAT server that's discoverable by clients inside their home networks and via DNSSD, and this requires probably passing the search domain as a DHCP option into the home network, which I am not seeing currently. I mean, I haven't done a wide review, but currently it anecdotally does not seem super common that home routers are implementing that functionality today. It might be because the service providers aren't advertising it in their DHCP offerings, but this is a space that I don't think has been necessarily that well explored, and would bear some investigation, and possibly alternatives. The main alternative I've been thinking about is making a DNS RR type that would describe an SG. I haven't started writing that draft yet, but that might be a reasonable way to allow a local ISP to manage the mapping from what a client app tries to join to a locally addressed SG. So that might be a draft that'll be coming to along this work. It's more drafts than I was expecting when I started. Anyway, in terms of next steps, I'd like to consider Dorm's last call, so I'd like to open that up for discussion now. The other thing I'm going to ask for is to put Dorm, CBAC, and AMBI into a cluster. The cluster being so that they can refer to one another and would become RFCs together, or in the order determined by their lack of loops. And then there are some new docs that are going to be relevant to this that seem likely to be on the way due to the security feedback we've received. And it's going to depend on sufficient interest being demonstrated. So if you know anybody who is willing to talk about this stuff, then make sure to get them on the list when I send out the invitation to join the MSEC, or whatever it will be. So with that, do please give me any questions or comments that you've got. Sandy. Hi. Hi.
Sandy,
I
you're
don't
up.
hear you yet.
Sandy, you're muted right now.
Hello, can you hear me now?
Hi, Sandy. Yeah, now I can hear you. Great.
Okay, thank you. I forgot to unmute myself. I have a question about the security multicast. I'd like to know if the multicast security will have some affection on the transport protocol, like MRD or PIM or other things.
I wouldn't expect so. MLD and PIM and beer, I would expect to be unaffected. In fact, I would hope that we could even consider. So the the security considerations, the sort of initial direction that I've not yet written down, and is highly subject to change, is that I'm going to be trying to make a quick version of this that uses a symmetric key for encryption, and maintains the same kind of out-of-band Unicast-based secure transfer of hashes to do the authentication of the data channel, of the multicast data channel, and the main difference with what it was before, which was just authenticating generic UDP packets, which may or may not be encrypted, is that the UDP packets for this part would be sort of specified as being quick encoded with a symmetric encryption key that is passed over an associated quick channel. The intent is to make it so that existing UDP payloads from outside, from like existing multicast applications, would be possible to translate into these UDP packets as quick datagrams and be transported with multicast that way, so that the applications themselves, even legacy applications, would not have to change at all. What you'd have to do is run a receiver sort of inside the sender that would pump out the quick packets and the authentication hashes. And the authentication hashes would have to be distributed to the receivers in a much smaller channel than the data channel, in the same way that Ambi works. But in terms of the transport under UDP, under the quick layer of UDP, there would be no change. And so anything that works today, MPLS, beer, PIM, all these things would be unaffected.
Okay. I see. Thank you.
Thanks.
Mentioned one of the pieces of feedback was, or a gating factor was, and I forget who you mentioned, which group, that know that there is a lack of demand for this. Is that pertinent from a technical standpoint? And that seems like a subjective discussion, and also one that would fly in the face of the existence theorem that you indeed have enough interest to be doing all of this. So can you? Is that a thing? Can you just say nobody wants this, so we're not going to do it?
Yeah, if you can't get enough interest, then they won't open a working group for you in general. But with that said, the specific case here was with regard to the multicast security for browsers in particular. The main question was like, well, what browsers are going to take this? They came from Ecker. He asked that both on the list and in the queue in SecDispatch, and made the point that, I mean, yeah, I've been talking to some Chromium people, but they're not eager for this, and seem pretty lukewarm on it. You know, I would like to get some counterexamples to speak up and say that. I mean, I think, you know, my response to his to what he said was that, well, they think it's probably not going to work. They're skeptical of this, and this is perhaps a justified position based on multicast history. They want to see, you know, more people engaged on this before they're willing to dive in, I assume. And that's some feedback I've gotten from others in the multicast community group. So I think increasing engagement would really show something worthwhile here. I should also maybe mention, you know, I'm starting to get a little bit more traction in this. Like Virgin Media previously had given us permission to say their name as having been involved in our trials and evaluated the tech and supportive of moving it forward. since then, or since last time, I've gotten, so Comcast said that they would, that they think this makes sense for the future. I rate them, like, they haven't looked at it as deeply, but they do think that this, as far as I can tell, looks promising, and they would like to see it happen. Likewise, I've gotten, so DAZN sent an email to the list, but it wasn't forwarded to the sec dispatch list. But I do feel comfortable saying, I think I will probably be forwarding it. But they also said that they're supportive of multicast standardization. Amazon also did give permission to say that we'd talk to them, and that they would like to see multicast capabilities happen. In news that may or may not be related, DAZN and Amazon each individually have signed major sports delivery deals for the upcoming years in the, like, 10 billion and 2.7 billion dollars and euros respectively, that they've publicly announced. And suddenly they're interested in multicast for some reason, or at least tentatively interested. So I mean, will it happen? Who knows, right? But these are names that are not nothing. I did not get a chance to say that in sec dispatch. My time was pretty short, but we'll probably be discussing it a little more. I mean, people can have an opinion and have it be wrong, but also it's true that there's not perhaps sufficient demonstrated interest, and that's going to have to change in order for the working group to really happen for the multicast security, I think.
You mentioned one of the other concerns was integrity. Does that mean, is that where you need to spin up a new working group, or is that just another draft that?
So Ambi actually addresses the integrity, and I don't think anybody said that it wouldn't work. I do think that if we do open a multicast security focused working group, that it would make sense to move Ambi into that working group instead of here, basically just for the sort of security expertise that would be bringing to bear on it. The original claim when we when I talked to a security AD and asked whether it would be reasonable to work on it in MBOND, or whether it would require another working group in the first place, was that, well, it's not using any novel crypto or authentication approaches. These are all well proven in other contexts, and so as long as it's not something that has like tricky trade-offs on crypto agility. We just have a very extensible sort of framework for how to identify which algorithms we're talking about via the Yang model. And so there's not many concerns on the security side with what was proposed, but I think having worked on it since then, there might be some subtleties in like the way the cores model works that I'd like to get some more security expert eyeballs on really before I'm comfortable with it. So that was also part of the advice, that we're going to need to have a security review of it, but I do think it would make better sense if there was an existing MSEC working group to live inside the MSEC working group once it's there. So I might propose moving it if possible at that time, but that's just a heads up for the future. There's nothing actionable I'm suggesting at the moment, besides like making a group.
So the integrity stuff that's needed is in Ambi. It's just a matter of getting more eyeballs on it.
Yeah, it's in Ambi. And there might be something very similar that would go into the Quick protocol itself that would be a little more integrated instead of purely out of band. But I think I'm gonna do it by just referring to Ambi. I need to experiment with that part and actually write it and write it up. So that's kind of TBD, but yes, the integrity approach outlined in Ambi, as far as I know, is looking like it's going to do the job for integrity.
Great, thanks. Any other questions for Jake?
Well, thank you very much. I'll get back to
All right.
notes.
Jake. Yep. Okay, Frederick and Saba and Frederick, you guys are up.
Yes.
So you can choose to share your screen, or you can click this button of share preloaded slides.
We would like to share the screen. Okay, I see that you are seeing the screen. Do you see the presentation?
Yes.
Thanks. Frederick, it's your part. Frederick?
Frederick, you're on mute.
I'm sorry. So thanks for the invitation. My name is Frederick Louis, and I'm here with Xaba Mate. We are working on behalf of Géant Association, which is the pan-European company managing the pan-European network. So we are here today to to talk about an exciting project we have started in 2019. Which is related to implement a routing stack based on various data planes. Next. So this is the agenda. Very quickly, we will explain what is the RAR free router project. The lessons learned regarding beer RFC implementation. The first beer experiment that has been launched in 2017 and that has been completed in 2021. The next point is the AMT relay implementation based on RFC 7450. And since today we have a very exciting beer combined to IMT implementation experiment that you can test yourself and listen the Hungarian hardware music and a bit of conclusion. Next. So basically, what is the RAR project? It's essentially combining three components, which is the control plane, multiple data planes, and create a specific interface between each data plane and the control plane. So the goal is to have one familiar platform that is able to propose multiple solutions, and each solution will address specific research and education use case. And the fun part is that Multicast is one of this use case. Next. So for now, we have multiple data planes based on P4. We have the BMV2 target, which is the virtual P4 switch, where you can train yourself and look at the RAR free router code. We have an implementation for Tofino, which is basically essentially the same code base, except the fact that you will see more pragma restraining features, because the Tofino ASIC is of course not unlimited in terms of resource compared to a virtual switch. We are looking at FPGAs, and which will come soon next year. We have a libpcap TCP dump library, and also DPDK. We have some discussion with in order to provide an NPL data plane. Next. So how do we test the code? Essentially, we have deployed a set of 4 nodes in Europe: Amsterdam, Frankfurt, Budapest, and Poznan. And so far, we attracted some attention to various organizations from around the world, and now we are pleased to welcome more nodes in North America and South America. We'll have soon new nodes in Asia, in Korea, for example. But and all of this corresponds to a beer, an entire beer domain that is spread onto the P4 lab. Now I think Saba, the floor is yours.
Okay, so what we have. So first of all, we introduced the beer MPLS encapsulation, that is this RefC, basically in software mode. That was the first that happened, and then I started to experiment with my home network with the beer. How can it transmit my frequently broadcast music sessions, and then this is what we mentioned, that the beer thing started in 2017 or about the time when this RefC became public. For this to happen, we needed obviously the interior gateway protocols to have the beer node index and the beer MPLS label base flooded within the domains. So this is why beer iSize extension and beer OSPF extensions started to appear in FreeRouter. This is again the same 2070 when it happened. This is the point when I would call you if you implement a networking operating system and you would like to and you have beer and would like to do some interoperability testings, then feel free to contact us. We are very happy to do some hacking with you. The thing is that beer OSPF extension have already interop tested. With the iSize extensions, fortunately, the Wireshark decodes it very well, but not yet tested in interop terms. Regarding the beer BGP draft, it is also supported since the beginning when it started to appear. It is basically when you send the prefix, then you cannot touch a beer attribute to it. Then that prefix will behave as it's shown as it's so in the IGP domains with the beer index. That is, you can send multicast packets to that prefix or parts of the prefix, and that will happen in beer encapsulation in this case. Also, we support the recursive version of this. That is, you get a prefix without the beer attribute, but the underlying root have a beer index. Then the packets also will send in beer encapsulation. And the last thing that we support with beer things, that is that is PIM in a beer encapsulation. It is needed for me just because this is how I multicast my music in the so-called global table here. And last but not the least, this year we as we started discussing with Andy and the guys from Juniper, then we added the Amt functionality. That is, we have two different parts. We have the Amt relay and also the Amt gateway, which also tested for interop with the video LAN codec, the VLC, and also with the public Amt relays that are provided by various universities in the States, and as far as I know, they are running Juniper Junos. Okay, and all the above that are mentioned here that we have are tested regularly over IPv4 and IPv6 addresses. experiment. So basically, as I said, I am running a small home network with some 25 or so nodes, and and all are participating in a beer domain, which is now since the last year connected to the P4 testbed that Frederick mentioned before. The main difference between the two is that my local home network is mostly running on DPDK data planes, while the P4 testbed adjunct is running on hardware-based switches. And since the last year, it is cross-connected with cross-connected, and we are doing an inter-AS beer setup between them since that time. Other prefixes are also exchanged, but there are some at least one prefix that have a beer index sent from my network. This is how, at the moment, the P4 testbed have a constant multicast flow. You can check various states of my home network with the links on this page, and the regular one of the regular broadcasts of my music is recorded on this on this demo link, which is basically a Unicasted video at the moment, but it is showing you that when I press the play button, then what happens in the network. So I show you that the end nodes start the IGMP. This is triggered by the VLC startup. Then it gets sent through the beer core within a PIM encapsulation. This is the beer beam. This is the PIM beer interrupt, and all these multicast packets within the core are transmitted in a beer at the moment. And since we have the DPDK data plane, I think it is 2 years old now. Then since then all this happens within the DPDK replication here, and this whole network is connected to public accessible Amt relay. This is the last line how you can start a VLC to use that Amt relay, and then you can listen through that Amt relay my my local home music, which is streaming basically always, and that's it. Frederick suggested to show you some other things here. Do you still see the terminal? Guys, do you see the terminal?
Yes.
Yes.
Fine. So two things that I would like to show you here is one part that is the Amt gateway at the moment. I have started it with a local router that I spawned up when the meeting started. It basically, at the moment, is very stupid configuration. It points a default multicast route to a random address which is on the tunnel interface, and tries to join that multicast group, which is sent out obviously through this next hop, which is on the tunnel interface. Basically, it points to the just introduced giant Amt relay, and the tunnel mode is Amt here. The things to note that the tunnel VRF, this is where the Amt packets are sent, is V1 at the moment, and the forwarding VRF, this is where the decapsulated multicasts are handled. This is the V2 VRF at the moment, and the things that I would like to show you here that is interesting. When I show the multicast route in V2 VRF for the given group, then the pockets and the bytes are increasing slowly. This is a constant stream here. Not too much on this node to show you, because this is just an Amt gateway, a local gateway that can decapsulate an Amt stream, and basically it can handle the multicast packets to the local LAN receivers if there are any. At the moment, it is just receiving the packets and discards them. So not too much as to show here. This is the server part. This is how an AMT relay that is configured in FreeRouter. Some basic security things that we added just today to allow only 8 clients from a subnet, a total of 256 listeners at all, and some access, some rate limiting on the new tunnels and load dropped items. Finally, an interface to bind to and the VRF to bind to, and an interface that you can that will be cloned for all the clients. This interface is the points toward the IMT clients that are that are starting AMT sessions to the same relay. Dummy IP address here, an access group to only accept IGMP packets. We must enable multicast IGMP here, and the same for V6. The same for V6. After all these things, at the moment that client is connected here, so this is why I have an AMT access interface cloned from the template here. So, and also the multicast group appeared here with one interface is on the outgoing interface list. And also the packets and the bytes are increasing on the group. It have an ingress interface here, which is a beer enabled interface. Sorry, but I can show you the the MPLS forwarding counters. So this is how it looks like, and you can spot that it is expressed in bytes and it increases. If we take a closer look on this label, then it is basically an OSPF v4 beer label. It's not sent out at all, and it is a beer local bit string, which is our beer index expressed in the beer bit string here, and we have some peers on this beer label. Basically, they are the same. They are the different nodes in the IGP domain, and they are expressed with these bit strings. As you can see, we have 2 routing interfaces here, and also the packets and the bytes are increasing. Okay, I think that's from the demo part. Let's see what else we have. Frederic? Frederic?
Yes, sorry, sorry again, I was muted. So just to let you know that in terms of status, we are in a very interesting position and surprising position, knowing that we started in 2019. We are now in the situation where we need to calibrate all profiles. So if we want to have a pure P router, we have to calibrate it in order to fit most of the to find a baseline that would fit of the most of the use case in our research and institution customer organization. And of course, beer is a multicast profile, and beer profile is a must-have because we have some users who have a multicast enabled application, and this is why we think that it's really great, because this P4 lab is giving us a way to be ahead in terms of innovation and new implementation. And just to let you know that you are free to test this AMT relay that is public. You have Xabamate showed you the link, and we can of course share the link with via the mailing list. The good news is that we can use this P4 lab to validate 2 things. The first solution of the problem was to provide a way to link users to multicast feed, which is the role of the IMT relay. But we think that we can solve the other problem, which is adding new source to this multicast platform, so that we can solve the other part of the problem, which will provide an end-to-end pass to the source toward the receivers, and that would be great, because we really think that this I wouldn't say a cost-effective solution for multicast, but just to know that this runs in an overlay on top of a real network is a very great asset to provide maybe a new way to provide multicast services that is totally independent and safe in terms of operational point of view. And this is also, I think, back in the time when I was working in the engineering team, it was a kind of scary to activate multicast, because at some point you don't know if you can jeopardize some resources from your backbone, and not. And in this case, this is totally not the case. We are free to explore new solution, and feel free to reach us. And I'm not sure, Xaba, if you have the link to the current world map.
Yes, I have.
Can you?
It's here.
Yes. So here, this is the lab that is spawned in Europe, of course. But if you look at the west part, we are starting to have new nodes in the US on the west coast, and on the North America, and in Latin America. And we will leverage new submarine cable in order to provide capacity. But just to let you know that all of this is a beer domain that can be used for testing. And also, one very good point is that if you are implementing a client, we have this beer domain is IPv6 enabled. So this means that you can implement your IPv6 AMT client and test it against this P4 lab if you don't have a specific way to test it. And I think that's pretty much about it. Thank you. Any questions?
Any questions?
Jake?
Yeah, that is very cool, guys. Nice work. So there's a couple of mailing lists you mentioned, I think. Are these for, is there a charter or purpose for these mailing lists? Like, I'm not clear. I'm interested in following this work. I'm not clear which is exactly the right one that I should sign up for. I think I'm on at least one already, but I'm not sure if that's for Jean. But I'm not sure if that's beyond.
Sorry, I wasn't clear. You are already on the multicast mailing list that is between, I would say, us. But I was mentioning the MBONED mailing list, so people can freely test it, get used to it, and approach it, discuss with us how we can improve things. Because for sure there are things to improve: security, encryption, or number of parallel client. And the good news is that this MTA relay has a 10 gig connection toward the P4 lab, and we hope that soon we'll move to 100 gigs, so we can have a very tremendous toy to play with. And the good news is that the more client we test, the more interoperable it will be, and even for you, it's a win-win situation. So if you are a pure VLC developer, I would like to create an IPv6 VLC client, feel free to reach us. It's for you. Just let us know. Sometimes there will be breakage and so on, but it's here for everyone to progress. On the contrary, we can add we can think about how to bind new source into this platform, even if it is an experimental platform. But in the end, the idea would be to solve this problem where we bind the source and the receivers. And after that, we will give you all the recipe to create your own platform in your own company, whatever, with your favorite hardware. And that's pretty much about it.
That's outstanding. Do you have a sort of timeline in mind for for when you'll be ingesting external traffic? And is that going to be using the sort of AMT and Dryad solution, or is that going to be, or did you have something else in mind?
And so the AMT relay, the second AMT relay in the P4 web is just started, but as I showcased in the demo, we have the AMT gateway functionality that can pull traffic from an existing AMT relay. And as I saw on the M2M, I cannot recall. So there is a public list where there are some interesting feeds. I think a NASA video with 8K and some other universities from the States, which are accessible through AMT. I played a bit back in time with them and noticed that Internet 2 has shut down its Multicast services. So basically, we have 3 days behind the domain that is the AMT relay, and some sources are reachable through one gateway and one relay, and the other sources behind the other relays. But so this giant AMT relay is just started today, but I have plans to populate some static tunnels to these public other AMT relays and have a constant feed from them and make them available into the giant multicast network, because the more streams, then we are more happy. So in summary, yes, we have plans, but I think it will happen in the upcoming days.
Okay, great. I may open a thread on the mailing list to talk a little bit about the DNS-based discovery mechanism and whether that would be feasible for you as well. Thank you.
That's perfect. One thing that we would also like to focus on is, of course, there is the technology aspect, where of course, all of us are technical people and we can find and understand things. But the real idea that we'd like to achieve in the end is to achieve something really brain dead simple. I would say that receivers and source should not know all of these complexities, or should work instantly. And this is the difficulty. Technically complex, but make things simple for users so that they just don't think about using anything else. They will just go this way because it's simple and it works. And this is the idea of this whole entropy that we are trying to bind.
Yeah,
or to
that's exactly what I want to talk about. Yeah, so we'll take that up offline, but I'll just say take a look at RFC 8777, and we'll talk some more. Thank you.
Tim, maybe you wanted to say something.
Yeah, I've got my hand up. Yeah, it does come back to content. You're absolutely right. At the moment, there's very little multicast content in the research and education networks. There's a project called EU METSAT, which is meteorological related data that's multicast. We looked on our UK network, Janet, and it's pretty much only EU METSAT traffic that's multicast. That's pretty much it. There's nothing else really. And as you said, Internet 2 have taken they didn't want to take the decision, but at the moment they don't have a multicast service because of the way they're transitioning to a new platform. They'll reinstate it later. So it's currently multicast is a bit of a second-class citizen for most things. So anything we can do, as you say, to make it easier would be great. So I think what we're looking to probably do with Rare and this multicast work is to find ways of allowing people just to stream even from bandwidth challenged areas, so that they can stream out and reach multiple people by automatically multicasting from that single stream that they're sending out and making it transparent to them as far as possible. So yeah, but yeah, multicast is not in a particularly happy state in RNE networks, which is unfortunate.
Any other questions? Saba, I have a question for you. What was your experience in implementing AMT? How much did you know about it before? Did you just pick up the spec? Was it really easy? Was it clear? Did it take months or weeks or hours?
So basically, I first heard, I think from you about ANT this spring. Then I did a lot of other things, and the first reading and the first impression was not too positive here, because whereas I am thinking about encapsulations and tuning like Pokemon, so catching them all is always good, but this kind to tune a multicast through to tune a multicast through Unicast domains didn't get too much love here. But then we had some chats with Fredrik and and mentioned that okay, that we should cache this Pokemon also. So afterwards I started reading the RFC. Initially, I also didn't find the needed parts for me, so I started reading the whole one, which is very rare here. I usually have the idea and I only seek for the pocket headers in the RFC. But then Frederick pointed out that okay, they are also there, but I have to scroll down a lot. At that point, so about 2 or 3 days passed with reading the RFC and catch the idea behind it. Afterwards, it was some hours, because adding a new channel encapsulation is not too hard here. Then at that point I was able to see the multicast streams from internet too. I mean, from the universities in states, and then adding the Amt relay was again some hours. Having them in data planes was about another day or two. So basically, a week passed after I I get the motivation to read the RFC, and I didn't found any issues. I mean, it was easy peasy as other RFCs.
It's very helpful feedback from this group, since it's good to know that that this doc was that the spec was useful for you. So thank you. And this is really great stuff. Frederick.
Just to conclude, I just would like to hammer the fact that this lab is open to anyone who want to improve their IMT client V4, V6. So we are now in the situation where we need very good clients so we can demonstrate things. So whether into using a browser or VLC or whatever, really, if you are really comfortable with IMT client software development, feel free to really to join to contact us, and we can open this. Of course, it's already open, but we can make sure that it's available for you.
I think the other thing we did discuss before this meeting was whether we might have some form of hackathon, and we had some ideas that we discussed with Jake and Nenny and others. So maybe we can try and focus on some useful hackathon for 113 that focuses on these things.
Great. Any other questions for Saba and Frederick? Cool. Well, thank you very much, guys. This is really interesting stuff, and the combination of beer and AMT is you know, potentially really powerful. So very neat, very useful stuff. And for the next section, I'm actually going to do a demo that hopefully addresses, well, it's an attempt in the direction of improving source content. So let me share my screen. Yes. Let's try this again here. All right. Can everyone see PowerPoint? I need to swap displays. How about now? Off-net sourcing for multicast streams. Is this what you can see?
Yep, you can see it.
All right, cool. All right, so this is a project that we had some interns this summer work on. So what is off-net sourcing? So today there's native sourcing, and it's been around for more than 2 decades on the MBONE, the multicast enabled part of the internet, and we can call that on-net. But the MBONE is a very small fraction of the internet. What AMT does is it allows off-net receiving. So if you're not on the multicast enabled network, you can access multicast content through an Amt tunnel, and you can receive. But what if you wanted to do the same? What if you wanted to source? And the fact is, most sources could potentially be on Unicast only networks. So we have an interesting portal for discovering and launching off-net receiving, and that is the Multicast Menu. Off-net sourcing, this is where users on Unicast only networks can stream some type of stream, say video, to a translator that's sitting on the MBONE, and that converts this stream from Unicast to multicast. Then it can be accessed. The idea is to access it natively for on-net receivers as well as AMT for off-net receivers. This is kind of how it would work, how it would look. We have the big I internet that's mostly Unicast only. We have the MBONE, the multicast enabled part of it, mostly RNE networks, and you have a multicast source and a multicast receiver that works the way it's always worked. Now, what if you have an off-net receiver, somebody on a Unicast only network who wants to receive? Well, we have these AMT relays, send it natively to the relay, and then the relay will send it over AMT to receivers on Unicast only networks. But what if you have an off-net source? And now we're introducing this Unicast to multicast translator, which will take a Unicast stream in, turn it into multicast, and spit it out to native or off-net receivers. So this translator was developed. It's essentially a Python script that translates, just very simply translates a Unicast stream to multicast. It was written by one of our interns named Giannis. It all it does is just rewrites the source and destination address. It picks a random SSM address out of 232. And it also posts and creates a new entry on the multicast menu. Giannis developed this in conjunction with Larry and Maki, kind of working together on a project. And it's this translator is deployed at George Washington University, thanks to Andrew Gallo. In terms of what are the goals here, we're just kind of working our way through functionality. What would be awesome is if we could stream from an iPhone or Android camera to stream video to the Unicast, to the translator. Right now we're just using VLC from a desktop, but getting that working would be really interesting. The translator, which just translates the source and destination, that's already done. Next would be, if it could index the stream, say for search. Right now, there's not a lot of streams. There's currently 0, and I'm going to create one. But, if this takes off, there could be zillions, and, creating a directory service so that you could subscribe to different types of streams, say, NatureCam / ZooCam / PandaCam, and then people could join that particular channel and be alerted every time there's a new PandaCam that pops up. So that's kind of the long-term vision. Also potentially, recording for look back purposes, since obviously multicast is a simultaneous, live by nature technology. And then receiver apps. Right now we're using VLC, but would be nice if we could use, something a little easier, something, an app for iOS and Android, as well as something that, if we could get this in the browser, this would be really, really wonderful. But for now we're using VLC, and, we'd love some other ideas as to make this easier. I think, Frederick said it well. If we could make these things easier so that any user on the internet could do it, that'd be great. Here's some references to see the code. This is an open source project. And if anybody's interested in getting involved, just shoot me an email. We'd love to, we have a Slack group of co-conspirators, or I think Jake has called it a cabal. If you want to join our cabal, please just shoot me an email. We'll add you to the Slack group. And with that, let me kind of give a show a demo. So first, can you see my, can you guys see my command line here?
Yeah, that looks good. A little bit small. If you could do a ++ maybe, but we can see it.
Sure. Yeah, sorry, especially those in the morning. Just you have to squint really hard. Make text bigger. Okay. All right. So here's the one command line. It's just runs VLC, launches a video, an MPEG-4, and it's sending it to this magical IP address here, which is the address of the translator, and which is looking on this certain port. So this is just a standard VLC command for sourcing. Let me say this. So folks in the audience, this is there is audience participation. Please check the chat window. I just sent a link to the multicast menu. For anybody who does have VLC4, be great to give it a shot. So this is currently the multicast menu, and you can click on any of these things, and it will launch one of the video streams on the MBone. So I'm about to hit return here on this, which will create that next one, that new stream. If I reload the multicast menu, you'll see we just created a new stream. If someone is able, would be great if you could join this stream. And I'm gonna join. Does anybody, I saw Jake, he does, so one of the things you can click on this, and just to see how it works, we can rename this to Cute Puppy Cam. All right, and we will upvote it a few times because this is the internet and it's all about self-promotion. And is anybody out there able to join this stream? Just shout out if you are.
I'm getting something. It's not quite playing yet. VLC is thinking about it.
So here's the AMT relay. You can actually see the relay. We can see some multicast. So the group address is 232.66.90.70. That is this. So you could see the incoming interface, and here's the downstream interface. There are two. This means there's two tunnels. So we can do a show AMT Tunnel Detail, and you can see these tunnels. This one is one AMT gateway. This happens to be a second laptop that's next to me. And here is another. And here's a third. So it looks like we have 3 receivers. Jake, I'm guessing one of you are one of these 2 addresses. Anyway,
yeah.
Are you seeing any video yet?
No, it looks like it's crashed my VLC, but I'll try it again. 1 sec.
I assure you, it's working. It's working on my VLC, so I'm gonna blame your.
Yeah, I've got an old version of 4 that's not working, but I connected.
Okay.
I tried the URL on the VLC from yesterday, and I have a message saying that, of course, I'm unable to open the MRL. So I'm not sure if you can see me coming, but at least I can show the stream. I can see the stream. Sorry.
What's the v4 address of the relay?
It
Is that the
is
20885 that I can see there?
So the relay is amt-relay.m2icast.net. Let me see here. And if you're using VLC4, a recently downloaded version of VLC4, it has by default, this is the relay it's just the default relay. But
so I did get some video after restarting, but it's a bit choppy and it's hanging again. It looks like it's dropping some frames or
all right.
or something. But
well, for what it's worth,
what resolution are you sending? What bit rate?
I think it's not that big. It's only like 8 megs. But I am. Oh, actually, here. Let's see here. Show multicast route detail. This is, yeah, about 8 megs. 8 megabytes per second.
Well, that's my problem then.
Yeah, you're still on dial-up.
Sorry.
No, it's a soup cannon wire.
Gotcha. Anyway, as anybody interested in working on this, as you can see, this is the idea. The multicast menu, by the way, Lauren, who developed it, is working on enhancing it to. She is close to releasing a 2.0 for the multicast menu. All right, so Frederick, you're seeing something? Is it cute? Okay, cool.
So if you want, I can just share my screen a little bit so you can see what I'm seeing. But
sure. Give it a shot.
Well, that makes you a relay then, Frederick.
Yes, share my screen, and I think it's this one. Can you see it?
Yes, there you go.
So it's great.
That is the video.
It was a little bit choppy at some point, but you see that this is in sync with the message on the left.
Yeah.
But it's
yeah. So we've come to discover VLC as VLC4. It's a beta version, and it is a little fragile. But anyway, it does work.
Excellent. Thanks.
All right. With that, we do have one last presentation. So Yisong, if you want to get things teed up, if you'd like to share your preloaded slides. But with that, as he does that, anybody have any questions about this project? And the idea and the vision for this is anybody can start streaming and sourcing something that anybody can start receiving. And it should lower the bar for generating multicast sources. Tim?
That's great. Thank you.
And this is an open source, simple Python script. So if anybody wants to launch a translator themselves, please let us know. We'd love to add you to the global translator pool, which currently consists of 1. But we'd like to do more. It's proof of concept, but you can see the vision here. Any other questions about off-net sourcing and the multicast translator? Jake?
Yeah, Lenny, if I stood up one of your translators with a DNS based relay instead of a fixed relay, would you be So we've talked about in I2 running. That's like next on the agenda, right? Is going to be running the ingest using Dryad to find the relays from external and pull it in. I'm just wondering if that's the. That's potentially interesting.
So the injection, so the translator just gets the source onto a multicast network. With Dryad, you could use that to hop from. I'd have to think about that.
I'm saying I would perhaps run your open source translator externally, just in my usual AWS multicast.
Yes.
Internal
Yeah,
AWS
absolutely.
instances, and then
definitely that would work.
And then that could be pulled in wherever. It could go directly from those relays to your network or other networks as well, but also could go natively to various I2 receivers. So that does look interesting and a useful source of traffic. The streams I'm running are. I mean, we've run some customer streams, but they usually want those a little more controlled. So if this works okay, it might be interesting to run. I'll see if I can fit it in and take a look. I might have to wait till after some other stuff first, though. But,
yes.
But if you would like somebody to run it on an instance like that, then let me know and I can see if I can help them.
Yeah, I definitely think that could work, and that could be a good test of Dryad. And for what it's worth, the next multicast menu will have the ability to specify a different relay. So right now it just uses the default relay in VLC, but which, like for example, if you could plug in a different relay, then it could launch that from a different relay. So that would work in conjunction with what Saba and his test stream. So yeah, that could, all these pieces can all work nicely together. But with that, it's I have to cut myself off and hand things over to Yisong. Frederick, yes, very quickly.
Just as a side note, and very quickly, we will try to play with this at least and see how we can use it in the P4 lab.
Great, awesome. All right, Yisong, you are up. Just share your preloaded slides where the join queue button is. There we go. Or share your screen. And okay. Yishang, you have the rest of the meeting. You can take us home.
Okay. Can you hear me now?
We hear you.
Oh, okay, thank you. Today I will present the multicast redundant ingress router failover. This is the second presentation in IETF. So firstly, I will give the very quick review of this draft. For this brief introduction, and the two IR and the ingress routers are used to avoid a single node failure for the multicast. And the two IRs are the UMH, the upstream multicast hub candidates for the ERs. The ER means the egress router. So for the PIM or BEER or RCPT, P2MP, or MMDP, whatever the specific multicast technologies, different functions can be used for the deployment. So there are three standby modes can be deployed for the IR switchover. In case of the IR's failure, that's the cold standby and the warm standby and the hot standby. And the details you can find in the draft. and the cost and the influence of the three modes are different, and no one of these three modes are the best choice. It depends on the actual network deployment. So the network administrator should select the appropriate mode. So that's the brief introduction of the draft. And this slide shows a minor update of the version 1. So the update is that in some deployments of the warm standby mode, and the IRs may in charge of different multicast flows. For example, if we have 10 multicast video flows, we can divide for the file for each of the IRs. All the IRs may charge of the different ERs for one specific flow. For example, for one flow, IR1 in charge of ER2 and ER1, and the IR2 in charge of ER3. The IRs can be backup devices for each other, and in case one IR fails, and the other IR may notify the IR may notify the other IR to forward the flow to the ERs. For example, for one specific flow, IR1 is in charge of ER1 and ER2, and the IR2 is in charge of ER3. And if IR1 fails, and it will notify the IR2, and IR2 will forward the multicast flow to the ER2, ER1, ER2, and ER3. So that's the update of this version. That's all of the draft. And any comments are welcomed for this draft. And we co-authors think it's ready to requesting the working group adoption. That's all. Thank you.
Jake, you're up.
Yeah, thanks. So in the draft, I didn't see how it detects failure and how it's doing the signaling from one to the other that it needs to be in charge of the ingest. There's a I mean, it talks. Sorry, go ahead. Yeah.
For this draft, we just give the a general way for the multicast root router failover, not involve the specific technology in that.
Okay, so I guess I think that this is a really valuable space to develop, but I'd like to see I guess some more specific. I'd like to see some recommended mechanisms at least. Like if some exist, then I'd like to see references to them, or you know, some guidance on how to do the detection that a failover is right, because it seems like that's a I thought that was necessary for this draft to be headed the right direction to me. But yeah, but thanks. I think this is this is a good space to work in, and I'm glad somebody's writing it up. Thank you.
Thank you. Thank you for your comments.
Sandy, was there something you had to add?
And we can add
You're
some
still on. Okay.
about. Sorry, can you hear me?
Yes.
Okay, I'd like to say, I think Jack's suggestion is very useful. We can add some description about the detection and the other functions and the other details in the draft in the future version. Thank you.
So for those who noticed, there was we had 2 polls: who has read the draft and who would like to see it adopted as a working group draft. We had 7 people who have read it, so that's a good sign. It's a third of the number of people on, and it looks like if you could just put your hand up, show of hands, who thinks that this is be a draft that would who would like to adopt this from the work as a working group document. So far we've got 6. Anybody else? No objections. So I think we'll take this to the list for an official working group adoption call. This was, by the way, presented back in 2009. And figured we'd re-present it again to get it fresh on people's minds first before the adoption call. So looks like there's support to adopt. So we'll take this officially to the list for an official adoption call. Please speak up on the list, both if you want to see it adopted or not adopted, and also, any suggestions that you see for the document are, of course, always welcome at all times. And it looks like I'm about to end that poll. There we have 7 who say yay and 1 person who did not raise a hand. So let the record show that. And any other questions or comments for this draft? Any other questions or comments for anything in general before we close down the session? Okay, with that, thanks for coming, and we'll see folks virtually or physically in IETF 113. Thanks, everybody.
Thank you, Lenny. Appreciate this. Thanks, everybody, for your work. This is actually a really good session. Good work all the way around.
Yes, lots of really cool stuff about real stuff that's actually happening in the network. So this was fun.
Yeah.
Thanks all.
Thanks, guys. See you next time.
Cheers, Jake.
Cheers, bye.